So, Tony.
Thanks very much. My qualifications for being here are 25 years in the industry writing software. I won't mention names, but I've been spending all my time doing import and export of files and exchanging data between different packages. It gives me great pleasure. And the other qualification is I've just come back from Houston, where I took part in a week-long ILab with Energistics, where we were exchanging data using RESQML amongst vendors and oil companies. And we had very positive results there. It gives me great pleasure to be here, actually, because this RESQML initiative and the previous one, Rescue, makes my life an awful lot easier for doing the data interchange that's demanded of us by our customers. By the way, if you have any questions during the presentation, please just speak up, and I'll know you're awake. And then, right, so motivation for RESQML, I think it's really just to enable lots of workflows, our existing workflows in oil companies, legacy ones and future ones, amongst different vendors, so that you're not tied to a single point of solution. That's the entire outline of the talk. This is a standard talk that was written by Energistics and is being delivered, I believe, simultaneously in Digital Energy conference over in the States. Well, not just at the moment. But, so why RESQML? It's just to facilitate the workflows. We do recognize that there's multiple applications. Best-in-class applications are being supplied all the time by different vendors, and you want to cherry pick and use them in your chosen workflows. And we want to be able to support that. It encourages the innovation from the small vendors. The other thing that's this business, QCing and traceability of the workflows and going back months later, years later, and reproducing them and seeing how the decisions were made. So traditionally, a lot of single applications, point applications, have not used metadata and really looked at the QC problem. We were just trying to get a single solution. But now it's becoming increasingly important. So RESQML has embodied the metadata that's needed to describe the source of the information, who gathered it, etc., and how it's passed through the workflow. And that's being captured at the moment. Needless to say, with increasing complexity of getting oil out of the ground and the power of computers, the models we're working with are bigger and more complex. To see how open we are, the members of the Energistics Consortium, I'm showing a presentation here, a slide from Roxar, which is a typical workflow that we all present to the industry. We're starting with structural modeling, going all the way through to simulation, flow-based simulation, and well planning. By background, I'm a physicist who transitioned from nuclear fusion into the oil business, and I'm really glad I did that 25 years ago. But I'm not a geophysicist or a geologist, but I know a lot of the terms. Now the other thing is, of course, is that it's not enough just to run this workflow once. We want to run it multiple times and capture the information and log in a very efficient way the results that were used. So handling vast amounts of data is becoming normal now, and we need much better techniques for storing that. And RESQML attempts to store that data in a very efficient way and to compress it as well. Problems with data transfer, well, they're legend, aren't they, really? There's a couple of examples Mike King from BP has put down here. The Horizon data that we got was okay, but it got damaged in transfer as we moved across different computer platforms, missing end-of-line characters or some nonsense, and then readers would fail. Well trajectories lost their datums. The 3D grid inverted in depth, or it came in, it was a time, but it comes in as depth, etc. And there's one that's particularly caused this problem in industry at the moment, is the mirror imaging of the grid properties, the J-flipping problem. I don't know if you know about this, but it's particularly annoying when you find that your wells are on the other side of the reservoir from where you drilled them. And it's entirely due to lossy information transferred during the exchange of information. And this is why RESQML has to exist and why it has to do this correctly. So I don't know if you're interested, but we're using XML. The existing RESQ format was a library, an API library written in C and C++, and it was shared amongst the vendors and all the contributors to the old RESQ consortium. But it, like all software, it rusted over time, and we found it very difficult to keep it alive as we moved to different operating systems. Now, the very intelligent decision of saying Energistics is just going to produce the schema, the specification for the data. You, as vendors and oil companies, go away and write your readers and writers according to the schema. And in fact, there's very powerful proxy generators to allow us to automatically write those readers and writers according to an XML schema. And that's a little picture of the schema there. We'll be drilling down into that in more detail. The other thing, as well as XML, is we've picked up on HDF5, which is didn't start in the oil business, but is being adopted by some oil reservoir simulation people to store their output results. It's an extremely efficient way of storing multi-dimensional data across platforms. It comes with compression, and we're very impressed by it and have adopted it and encourage people to store bulk data in so their grid properties, etc., the simulation results can be stored in this format. And again, it comes with an API to read and write that. And in fact, Energistics has been funding the latest .NET development of that API. So the XML schema, as I said, we're just defining the data standard, and you go and you come along to an ILab, and it fast tracks you to write your readers and writers when you learn about the experience of the other vendors. We were very open in sharing that. The other thing that's been done is the EPSD. All the data in this schema now comes with spatial information. Traditionally, that wasn't passed around as we moved from geology into simulation. So that's something that helps an awful lot with the QC and not getting your well in the wrong place. This Dublin Core for metadata is just all the bibliographic and citation and author information. There's 15 entities that are in the XML schema to describe where that information came from, and that's passed around with key information as well. So we didn't have to invent that, we just picked it up from a description. And of course, RESQML is just part of a family of ML products. WITSML, I'm sure you're very familiar with, and ProdML, and we are beginning to integrate them. In fact, we reference information in WITSML rather than duplicate it in the RESQML side. And yes, there's a picture of the architecture. We can spend half an hour on that if you want, or I'll flip it on. I don't know. But look, trust me, I'm a developer. You know, the readers and writers work according to this. Yeah, so here's an example of the information, spatial information, as I mentioned, the volume of interest that you're looking at, where you've extracted from maybe a larger part of the reservoir. Interface feature set, that's things like horizons and faults. The gridded volume that you've built, there can be many of them, of course, and they can be tied to horizons, etc., and have different number of layering schemes. Property groups, now they can be static information from the geological modeling, simulation time data marked with timestamps, and property kind, the units that we're using. Again, RESQ, the existing one, wasn't terribly good at handling units. It was just a string that was passed around. Now it's much tighter, and there's a schema for describing the units. Because as engineers, you know how important it is to get the units correct. Otherwise, you're out by factors you wouldn't want to think about. Yeah, I've actually repeated that. So we can drill down to the bottom of this. Maybe I should come back. You can probably still hear me. Yeah, we drill down an explicit representation. Can you still hear me?
Or are you trying to record this?
Okay, can you? So explicit representations of the grid. Basically, that's the pillar type representation you're maybe familiar with. We'll come and talk about that in detail, where we're looking at node information down the pillars. We have very verbose descriptions where you have cellular geometry, where you can record the 8 corners, etc. Although all of this data can be stored in XML format, which is an ASCII format and is ideal for exchanging, it's far too voluminous. So we'd encourage people to use the HDF option that most readers and writers supply. Local grid refinement, where you need more detail around long wells, we'll support that. blocked wells, well, the wells come in, and the important thing for us, for example, in the simulation world is what cells the wells connect to, and flow comes in, so that information is passed along. So other simulators can connect the well to the same grid blocks and then produce similar results, hopefully. The non-standard adjacency set, it's one thing to transfer geometry in a grid form between different vendors, but it's what we call the topology, the set of connections on that grid, actually what transmissibilities exist, what's the flow and the strength of those. That's very important that we exchange that information with fidelity as well. Otherwise, you can get flow through faults, for example, as a classic mistake that's happening, where it should have been sealing in one person's model, because when they read the grid, they actually get slivers of intersections across the fault, and you end up getting considerable flow where you expected it to be sealing. And that's an error you only find out after having done very expensive simulations. Right, so spatial references are now very common in all our data. We use GUIDs, these global unique identifiers, that as you pass the information around, give you the traceability and from where it's come from. Oh, apologize. The structural data, the interface feature set, horizons and faults, comes in as triangular data structures, and then we can do intersections on them in our readers to intersect with the grid. And of course, the 3D summary. I mean, it is
because if it's global, presumably
it's completely global and unique, because the chances we generate it on the fly, and the chances of coinciding with somebody else is zero.
Okay, so it's almost a random number, almost. Then is it, or
well, it is a random number that's unique. Yes.
Yeah. Okay.
But there's a very clever algorithm to generate that random number. This is an example, for example, of the grid. Geology, of course, is much more complex. Now we're handling much more complex geology, and we have to have much more complex descriptions of the grids and the pillars when we store them. And RESQML has stepped up to handle that complexity.
This is meant to be an open standard, right?
Oh, yes.
But you're using Microsoft kind of GUIDs as a
I think that's standard. No, I think that's open as well, that GUID, isn't it?
Open for Microsoft.
Right. I'll go on and I'll go into Wikipedia after this talk and find out, and I'll come and see you. But as far as I'm concerned, no, RESQML Energistics only use open. It's guaranteed to be an open standard. So if I'm wrong about the Microsoft connection, maybe they invented GUIDs, but whoever's producing it now, it should be unique. Good question, and I will get to the bottom of that. I don't know if you're interested in the geometry, but yes, we have to handle much more complex geology here, and we've stepped up to doing that in a very compressed way with the HDF5 and the use of pillars. And of course, the relationships are very important between the root grids and any local grid refinements, because you may have multiple sets of local grid refinements that you're trying to get an accurate result with your simulation, and you need to know which set was used in which particular simulation. This topology and the actual connections between the faces of the cells, IJK1 to IJK2, and the strength of the connection is important to capture, so that you will get the same simulation results when you move it from one simulator to another. Very complex stratigraphy, lots of pinched out layers here over which we want to jump. This goes from K10 to K15, for example. And it's important that some simulator doesn't realize, oh, that sliver actually is a cell, and I'm going to have volume and flow in there. So again, the topology helps with that. Complex faulting, either as pillar faults or stair-step faults, are handled both in RESQML. Properties, we can have properties based on cells or properties based on the interface between them, so that's transmissibility. Both flow transmissibility and thermal can be handled. Gridded properties, again, static or time steps. The blocked wells, the subset of grids that are connected to the wells. I've said about the non-standard adjacency. And HDF5, we'll come to that in a minute. But the great thing about HDF5 is it supports this slabbing, this IJK slicing through the grid to look at cross-sections or to extract zones or segments of information. very quickly from the bulk data. So it's a general query, if you like, that we can support using HDF5. And again, we've noticed that a lot of the time on the simulator, we only look at the active cells, the one with pore volume. And that can be quite a small percentage of the total number of cells used to model the grid. And generally, we just store that information to get the compression. But HDF5 is clever enough in its compression to just throw the original set of cells at it, and it compresses it down, which means you're getting the full set of cells that were used in the previous application given to you, and you don't have to reverse engineer anything, something that causes us a lot of trouble in application. So HDF5, there's an example of the compressions. We're getting a factor of 10 compression when we go from full set of active cells to the active set. But as I said, there's information being lost there during that data exchange, and we'd rather not do that. Whereas if we use HDF5, we're getting better compression when we allow that system to do it on the bulk of floating point information. Doubles that we're sending across. So 1.5 million cells isn't big in today's world. You know, we've been playing with 100 million cells in some of the simulations we're looking at. This is why we need to step up to this HDF5 technology. I think Mike King originally did this talk, and 30-mile reservoir here, I guess the cells we're talking about are the size of this room, and we're trying to model. 5 of the vendors do have readers and writers at the moment. We're quite happy with the exchange that's going on at the moment, having validated in the ILab. There's another ILab coming up in August, and then there's a version 1.1 coming out around about September. And I think you'll begin to see it emerge from the vendors. As all the vendors are not aligned on the release cycle, so until you've got 1 year's probably gone by, then we'll all be exchanging information on version 1.1 with a couple of bug fixes. We commit to 3 ILabs a year where we go and we test and exchange everything. There's an FTP site where the data sits there, and we encourage oil companies to give us data sets that we can exercise the latest versions of RESQML. So, yeah, really, you have to check with your vendors when they're going to support this. But there's a lot of pressure. I mean, rescue is ubiquitous in the industry. There's a lot of people using it, and we recognize that it's going to be there for a while, so there's legacy models stored in the rescue format. There isn't a migration path directly to RESQML from rescue files. You would go through your vendor's reader and then the new writer to get the RESQML version. That's the way we're doing it anyway. So I think it's going to be taken up quite quickly within the industry, this. So, roadmap. Ooh, emphasis on goods, yes, and we'll find out who owns them. But metadata for traceability and workflow, that's going to be key to what we're doing. The grids, corner point cells at the moment, I think I'll come on to discuss unstructured grids later, because these 8 corners of the cell is insufficient to describe the geology that we're being asked to model. So you're going to find these unstructured grids being used. Improved information in the topological description so that we don't have to reverse engineer the flow patterns within the cells. And a complete replacement of all the rescue features, particularly units, I think, is the most important one there to get them right. And the member companies, there's a considerable list of oil companies involved where we're Energistics, and myself as a vendor is driven by the oil companies, what information they want in the RESQML, what do they want to exchange. And we work alongside competitors or other vendors to make sure that the data transfers properly. And it's fun working with that team of guys. Now, I've stood here and been hopefully evangelical on RESQML. Don't take my word for it. Totale are a leading light in pushing RESQML, and they've got 2 or 3 people dedicated to designing it, particularly on the structural framework side, where Rescue, which had 2 flavors, there was a Rescue A and a Rescue B, and Rescue A never really picked up, where this is just descriptions of horizons and faults for watertight models, which would then be turned into grids by our software. So he's pushing it very hard, and I won't read what he said, but I believe it. So I didn't get any questions there. That's because it was all so obvious, or of no interest.
No, we did interrupt a few times.
Yeah. I think.
Okay, thank you. Are there any questions that people wish to raise? Again, if you can state who you are.
With Selimonite, but I'm still loosely related with Energistics and its predecessor. Is this rescue model going to become the internal model of the applications, do you think, or is it going to stand out as separate as a exchange model, which involves transformations in and out of each vendor's different internal?
Right. So certainly the latter is always going to be used as a description. Now, because it's so generic, my internal model, we've come as a bunch of vendors and brought our ideas of the internal model, and that's influenced the RESQML model. So there's a very close mapping that allows us to quickly write readers and writers and honour the fidelity of the information that's in our internal model when we put it out to RESQML. I mean, typically, I know in one product close to me, we, for example, didn't support hierarchies of zonation within the reservoir, yet other products did. So when I flattened my hierarchy out to go to rescue, somebody there wasn't the information to recover that hierarchy when it was read in, and that's precisely the sort of error that we want to avoid. So therefore, you'll find over time that there will be considerable overlap between internal and the external exchange model. Yeah, and as oil companies, you'll see where the problems are at the boundaries, and they'll be ironed out. So yeah.
Thanks.
Any other questions? Anybody got anything to raise?
What about the crossover with PPDM, or is that something we'd rather not talk about?
Well, I'm not in a position. Yeah, I couldn't answer that. But presumably we will embrace the PPDM. Just remind me, what is it? It's a big database for.
Yeah, it's a bit relational database model which is used by the industry.
Right. Presumably somebody will write readers and writers to RESQML for that at some stage. But yeah, no, it's not my area, I'm afraid. I concentrate on the grid.
Question at the front here.
Will it have the capacity to deal with multi-resolution cells in a model?
So that's the LGRs, the local grid refinement?
Yes.
Yes, it does.
It
Very
does
much
already.
so.
Oh, good.
Both local grid refinement and coarsening, and nested, in fact, what we call them. Yeah, absolutely. Some multiple domains. And multiple reservoirs connected only by wellbores is, again, important. Yeah, so.
Anybody? I've just got one other point I'd like to raise, which is one of the aspects that we're finding in the since Sarbanes-Oxley and the Shell debacle on reserves is actually being able to get to the audit trail of exactly how that reserve number was calculated, and what, from what I understood, you're saying that RESQML is designed to help with that.
Yes. So it's the responsibility of the vendor to make sure that their workflows, where they've got history for how the data was generated, is exported using the meta information in the Dublin Core part of the XML description to actually, so that can be reproduced. Yeah.
So in that case, could you use RESQML as a industry neutral system for preserving models, so that is it designed? Yes. You can create a file which could actually say this is RESQML. I can put it to one side, and then 5 years down the road, I can take it and load it into any system that I might choose to.
There's a very lively debate at the moment with Totale driving it to do it for archiving purposes as well, and I think it will start to get used as that. We, as developers, want to get version 1 and 2 out first and bedded down before we think of archiving. We want to get it quite a static model, or robust. Okay.
Anybody else? Okay, thank you very much, Keith.
Thank you very much.
No, sorry, Tony.